So last time, starting for 1.3. So last time I start for the section 1.3. So section 1.3 is about algebraic expression. But I will give you another brief for the section 1.3 algebraic. So what is the meaning of algebraic expression before we start this section? So I'll give you a brief for the meaning of algebraic expression. So if I have variables, for example, variables such as x, y, z, all of these variables, and I have real numbers also with this and real numbers. The variables combined to this real numbers, combining to each other by summation, subtraction, multiplication, dividing, or with power, or with root. This is all of them make algebraic expression. Okay, let me give you example to explain what's the meaning of algebraic expression. For example, something like that, 2x to the power 2 minus 3x plus 4. Look, we have numbers 2, 3, 4, and we have variables x, such that x raised to the power, look, here power 2, x raised to the power 1, here without any variable. All these numbers and variables combined to each other, this thing here is called algebraic expression. So this is an example for algebraic expression. Another example, square root of x plus 10. Look, here numbers, root, variables, combining by using sum. So this thing is called algebraic expression. Another example, y minus 2z over y square plus 4. This is algebraic expression. We have y variable, we have numbers, we have 4, we have power, we have dividing. So this is algebraic expression. And last time I talk about polynomials. Let me give you a brief of the definition. What is a polynomial? So polynomial is an expression of plus 1, something looks like an xn, an minus 1, xn minus 1 plus a1x plus a0, such that this and this, the a minus 1, all of them are real numbers. The an minus 1, a1, a0, real numbers. and the n here, n minus 1, the n is a natural number. Or 0. The n here must be natural. Means it is 1, 2, 3, 4, 5, 6, 7, 8, something like that. Okay. Any question about this two definition? Okay. So okay. So again, example for polynomials. Here, did you take the attendance? Yeah, I took it. So now, example for polynomials. Again, like 2x raised to the power 3 plus 4x plus 5. Look, this is real numbers, real numbers, real numbers. Here is variable x and x, and look here, it's natural. Number 3 is natural numbers. This is example for polynomial. What about these things? Is it polynomial? Is it polynomial, this thing? This is, yes, it's a polynomial. This is a polynomial. This is polynomial or not? Again, the definition for polynomial.
Yes,
A,
it is.
the n plus an minus 1, xn minus 1 plus plus a1 x plus a0. This is, who said yes? But if I want to change this as look like x square root of x plus 10, it's exactly look like x to the power 1/2 plus 10. The 1/2 is a natural number. The natural 1/2 is a natural number. This is real number. This is variable. This is natural number. So it's not polynomial. So this is not polynomial. Why? Because 1/2 is not natural number. To be polynomial must be the power natural number or 0. This does not belong to the natural numbers. It makes sense? So the answer here, no. It's not a polynomial. Okay. Last time, can you repeat? Okay. I said a polynomial, it must be look like this, an xn plus an minus 1. We go back to the definition. An xn plus an minus 1 xn to a1 x plus a0. I said a0, a1, an minus, all of them real numbers. X, all of them are variable, x and x and x. But here the n must be natural numbers or 0. And this n must be natural number. If we go to the example here, the first one, we have a real numbers 5, 4, 3 is real number. X is a variable, 3, and here we have 1. 3 and 1 is a natural number. So this is polynomial. But for the second part here, square root of x plus 10. If we repeated this one, write it in different way, we write it radical to rational exponent. This is equal x to the power 1 over 2 plus 10. The 1 over 2 is not natural numbers. That means all this is not a polynomial. Another example, 2x squared plus 3x to 1 over 4 plus 6. Is it a polynomial? This is polynomial. It's a polynomial or not? Again, 2, 3, 6 are real numbers. X a variable, 2 it's natural number, 1 over 4 is not a natural number. That means this not a polynomial. No, it's not a polynomial because 1 over 4 is not natural number. Make sense? Last time I talked about adding and subtracting polynomial, and I gave example for adding polynomial. This time I'm going to do, I give you example for subtracting polynomial. So last time I did these things. Now I'm going to give example for subtracting polynomial. Okay. For example, let's subtract x to the power 3 minus 6x squared plus 2x plus 4 minus x3 plus 5x to the power 2 minus 7x. So how we can solve something like that? Combine like terms, exactly. So first things, before we do the combine like terms, but this is the general idea, combine like terms, we distribute the minus inside the parentheses. This is the first thing we have to do. So this is equal x to the power 3 minus 6x squared plus 2x plus 4. Now we distribute the minus inside. What's the answer? Who will help me? Who will help?
It's negative x cubed minus 5x squared plus 7x.
Exactly. So negative x cubed minus 5x squared plus 7x. Now we're using the combined like terms. That means all is equal. All the same variables raised to the same power, we combine together. So this variable, all of them has the same variable x. The same power, x to the power 3, we combine it to this x to the power 3. So x to the power 3 minus x to the power 3. Okay. Plus. Here we have minus 6x squared. Minus 6x squared. We have here minus 5x squared. Minus 5x squared. We have another square? No. We combine together. Plus. We have 2x here. We have 7x. We have 4 only. We don't have any numbers. So plus 4. Okay. So x to the power 3 or x cubed minus x cubed is 0. So this is 0. Minus 6x squared minus 5x squared is, what is the answer? Minus 11x squared. Plus 2x plus 7x is 9x plus 4. Any question? That's it. We finish. So now let's go to the multiplying algebraic expression. So last time we did the summation. This time we do the subtraction. We distribute a minus inside the parentheses. Then we combine like terms and we get this answer. Now let's go to the multiplying algebraic expression. So the idea here, we're using the distributive property from first section in this class. So I will explain that by giving example. Find 2x plus 1 times 3x minus 5. So how we think about this by using the distributive property. I mean,
distribute the 2 to the other part parentheses.
That's me, like he said, we multiply the 2x to this parentheses and the 1 to this parentheses. So this is equal 2x times 3x minus 5 plus 1. The 1 is like 1 times 3x minus 5. We distribute it again. This one with this one. This. And the 1. So again, 2x times 3x plus 2x times the minus 5 plus, here the 1. 1 multiplying anything, keeping like the second term without change. 3x minus 5. We're simplifying. So 2 times 3 is 6. X times x is x squared. 2 times 2x times minus 5 is minus 10x plus 3x minus 5. Now minus 10x plus 3x is 7x. So the answer is 6x squared minus 7x minus 5. Any question?
No, sir.
Okay. So this is exactly by using the distributive property. I give you another example. The example is 8 times x squared minus 3x plus 5 minus 7 x squared minus 2x plus 1. How we can solve something like that?
Distribution.
What is that? What we have to do?
We distribute the 8 and the 7 inside the parentheses.
Perfect. So we distributed the 8 inside the parentheses. Minus 7, everything again inside the parentheses. So what we get? 8 times this is 8x.
To be 8x squared minus 24x plus 40.
Exactly. So again, will be like 8x squared minus 24x plus 40.
Minus 7x squared
Minus 7
plus
x squared
14x squared
plus
minus 7.
14x minus 7. Now we simplify it by combining like terms. So it will be like 8x squared minus 7x squared plus. So this one, this one, with this one, the numbers with the numbers. So plus minus 24x plus 14x plus 40 minus 7. Now 8 minus 7 is 1. So that is x squared. Minus 24 plus 14 is minus 10x. 40 minus 7 is
33.
So this is the answer. Any question? Okay. Now let's go to the special product formulas. Anyone has a question before we go to something new? No, no one has a question. Okay. So now special product formulas. So let, for example, let A and B are algebraic expression. So the first property, we have some properties. A squared minus B squared is equal A minus B times A plus B. Second one, this formula you have to memorize. A plus B squared is equal the first term squared plus 2 times the first term times the second term plus the second term squared. So the first one, what it still was, if no, it will be complex number, but we're talking about only real numbers. It's not gonna work here in this material. The answer is no. Only subtract minus. Number 3, here it's work for minus. A minus B squared is equal first one square minus 2 first times the second plus the second square. Okay. I give example. So 3x plus 5 square. How do you think about this one? How we can think it for the first one? Three x plus 5, all of this square. Look to the second one.
It will be 9s squared plus 30s plus 25.
Exactly. So he thinking for this by using the second product formula. Here, 3x. This is my A, capital A. And the 5, this is my capital B. And we're applying this formula. So the first term square, that means 3x, all of this square, plus 2 times the first term times the second term, 2 times 3x times the 5, plus the second term square, that means the 5 square. And this is equal 3 square x square minus x square plus 2 times 3 times 5 is 30 x plus 25. Okay. It's clear.
Yes.
Okay, I give you another example. So second example. Fifth root of x times 2x minus 7x squared. Square root of x. How are you thinking about this one? So again, I'm using the distributive, right? How I solve it? So I distribute the fifth root of x times the first term and minus the fifth root of 5x times the second term. So 2x times the fifth root of x minus 7x squared the fifth root of x. So how we can simplify these things? How we can change the radical to rational exponent from last lecture? So this is equal to x Yes, exactly, Angel. This is times x. Here, like I said last time, let me remind you what I said last time. I said last time, if I have radical look like this, the nth root, I mean, have any real number raised to the power n, m over n. This is exactly look like as a radical n a to the m. So here we have the radical. Okay, here we have the radical. We need to change it as rational exponent like this. So my m here is 1 and my n is 5. So it'll be like 1 over 5 minus 7. Again, the same idea, x 1 over 2 times x 1 over 5. And here I have 1. Now I have the same base, x, and x. X times x to the power 1 times x to the power 1 over 5. I can make it one, and he said 6 over 5. This is true. Why? Because I said, again, from the first class, if I have something like that, x to the raised to the power a times x raised to the power b, this would mean x over a plus b. So again, here I have x to the power 1 plus over x to the power 1 over 5. So this is equal x to the power 1 plus 1 over 5. And 1 plus 1 over 5 is 6 over 5. Minus 7 x 1 over 5 plus 1 over 2 plus 1 over 5. And they give me 2. 1 plus 1 over 5. Let me do it here. 1 plus 1 over 5 is equal 5 over 5 plus 1 over 5. And they have the same denominator, equals 6 over 5. For the second part, 1 over 2 plus 1 over 5. We have to do cross multiply, 7 over 10 exactly. So 1 times 5 is 5 plus 1 times 2 is 2 over 5 times 2 is 10. This equals 7 over 10. So go back again to the example. So we get 2 times x over this one, 6 over 5, minus 7 x raised to the power this one, 7 over 5, 7 over 10. That's it. Any question? Okay. So now let's go to the, give you another example. How we solve something like that, 2x, by using the special property formula. 2x plus square root of y here here y. By using this properties here, this, how we can solve this example by using this. How we can solve it? We have here 2x. This is my A, my B, the same A, the same B. Who will solve this one? Look, A, it's similar to A. B, it's similar to B. Minus y squared, right? So this is exactly look like the formula that said A minus B times A plus B. And they said A squared minus B squared. So my A here is 2x. That means 2x squared minus the square root of y squared. What does that give me? 2x squared is 4x squared, right? So 4x squared minus, what is the answer for this one? It's not y. It is close to y, but it's not y. Not minus y. Do you remember when I said, when I see radical y, for example, n and n, and said this is equal y, or this is equal absolute value for y. This is equal y when n is odd. Do you remember last class? And n is even. And here is even. It's true. And this is the square root of y, everything to the 2. This means, what's the answer? The absolute value of y. So this is the final answer. Any question? Clear now? So we finish everything about adding, subtracting, multiplying polynomials. Now let's go to something new. It's called factoring common factor. So first thing, I will teach you how to factor common factor, but first things I have to give you a definition for like, you have to know. If I see something like that, x squared minus 4 equal, the factor for this one is x minus 2 times x plus 2 by using the properties in the back, by using this property, this one, number 1. So here x squared minus 4 is equal x minus 2 times x plus 2. So from here to here is called factoring. But the opposite way is called expanding. So when you see something like that, going to parentheses is called factoring. From parentheses, go back without parentheses is called expanding. I give example, and I will explain by the example how we can factor. So the question is, factoring each expression. First one is 3x squared minus 6x. How we can factor something like that? So to factor something like that, I'm using something is called the greatest common factor. So I'm looking for this is the first term, and this is second term. So I'm looking for the greatest common factor between the numbers of the first term and the second term. What's the greatest common factor for the numbers? Is 3. Exactly. Thank you. Now we're looking for the variable. What's the greatest common factor for the variable x and x squared? Is x. It is x. Now we open the parentheses. Now I divide this term by this. What I get? 3x squared dividing by 3x is x. I divide this one, second term, by 3x. What I get is minus 2, exactly. So the factoring for this one is 3x times x minus 2. This is the first example. That's it. So we're looking for the greatest common factor by greatest common factor. Okay. Now let's go to the second example. So number 2, factor 2x plus 4 times x minus 3 minus 5 times x minus 3. So what's the greatest common factor between this term and this term? We have two terms. Look, it is x minus 3, Angel. That's true. So we're looking for the greatest common factor between this term and this term. It's x minus 3. Now, you're dividing this by this. What do you get? When you divide this term by this, I cancel x minus 3 with x minus 3, and it remains this term, this thing only. 2x plus 4. For the second term, this one, when I divide it by this x minus 3, what I get? What I get? What I get before I simplify it? What I get when I simplify?
Negative
When
5.
Negative 5, exactly. So I get now x minus 3 times this big parentheses. Now, inside the parentheses here, I can simplify it such that I have 2x plus 4 minus 5. So I have two numbers. I can do some calculation. What does that give me? Two x plus 4 minus 5. What does that give? Minus 1. Yes. So this is the final answer. This is the factor for this one. Any question? Okay. So we learned the greatest common factor. Okay, now let's go to the factoring trinomial. Factoring trinomial. So we're going to factor a polynomial of the form. So we're going to factor a polynomial Yes, exactly, Angel. of the form x squared plus bx plus c. So how we can factor something like that? So actually this is equal when we factor it, x squared plus bx plus c. When we factor it, it should be look like x plus r times x plus s, such that r times s must be equal c, the c, and r plus s must equal b. So we're looking for two numbers. The multiply for these numbers, the multiply for those two numbers, they give me c, and the summation of these two numbers is they give me b. Yes, the multiply for those two numbers, they give me c, and the summation of these two numbers, they give me b. Let me give you an example, explain what I said. So the question is factor x squared plus 7x plus 12. So first things how we think about it. We're looking for two numbers. If I multiply these two numbers, they give me 12. If I do sum of these two numbers, they give me 7.
4 and 3.
What is that? 4 and 3.
Yes.
Okay. So he's right. 4 and 3. So first thing to think about this question for student he don't know. I'm looking for two numbers. If I multiply, they give me 12. What's the two numbers? I can multiply 1 times 12. Or I can multiply 6 times 2. Or I can multiply 4 times 3. But is 1 plus 12, they give me 7. 1 plus 12 is give me 13, not 7. So this one, I don't need it. Okay. Now 6 times 2 is 12. But 6 plus 2 is 8. It's not 7. That means I don't need it. Third one, 4 times 3 is 12. And 4 plus 3 is 7. So great. This is what I need. Look here, 7. So that means this is what I need. So the factor for x squared plus 7x plus 12 is x plus 4 times x plus 3. Okay, this is the answer. Any question? Okay, another example if there is no question. X squared minus 2x minus 3. How we can think about this one? Give me two numbers. If I multiply, they give me 3. Minus 3.
Negative 3 and 1.
So negative. I need two numbers. If I multiply these two numbers, they give me minus 3. And the summation of them is minus 2. So I go here and I factor it like a previous idea. What's the numbers I can multiply? They give me negative 3. So 3 times minus 1, they give me minus 3, right? But what's the summation of them? Minus 1. It's 2. It's not negative 2. It's not minus 2. So this is not my answer. What about if I multiply negative 3 times 1? This is give me minus 3. What's the summation? Is negative 2. Exactly, this is what I need. So x squared minus 2x minus 3 is x minus 3, this number, times x plus 1. The 1 is positive. Make sense? Any question? Okay. So now let's go to special factoring formulas. If there is no question. Any question before we go? So special factoring formulas. So we have to know for the first one, a squared minus b squared. This is like before exactly. It's like a minus b, but we're going to use this for factoring. A plus 4, a plus b. This one is called the difference of square. Second one is a plus b square is equal to the first one square plus 2ab plus b square. This is called perfect square. Third one is a minus b square is equal to a square minus 2ab plus b square. And this is again, it's called perfect square formula. Okay, this is exactly like the previous slide formulas here. But here we use it for algebraic expression. Here we're going to use it as in the factoring. Any question? Okay, let's use this special factoring formulas in our example. Example. So factor for x squared minus 25. How can I factor this one? How can I factor? By using, this is perfect sequel, do you think? Look back. Yeah, it looks like this, right? Something like that. Now, what about the first one? It's not perfect. This is the perfect sequel, number 2, number 3. Number 1 is called difference of sequel. Look at the first one. It looks like this one. So this is not perfect square. This is called difference of square. Okay. So this is my A, and this is my B. Okay. So again, the difference equals said A square minus B square. It is A minus B times A plus B. So again, here if I want to make it like A square, it looks like 2x everything square minus 5 everything square. That's true or not? 2x everything is square because 2 to the 2 is 4, x to the 2 is x squared, minus 5 to the 2 is 25. So now this look like this exactly. Okay. So if I want to use applying this formula, the first term 2x minus second term minus 5 times first term 2x plus the second term plus 5. Yes, exactly, Angel. 2x plus 5, 2x minus 5. Well, this is true. Plus minus 5. Perfect. Makes sense for everyone in the class? Shanshan, it's clear for you? Shirley, Noel, Rahina. Any questions so far? Okay. Perfect. There is no question. So now, this is called again the difference of square. I'll give you another example. It will be the last example in this section, and I will post the web sign today for this one. Example. Factor this one. 3x to the power 4 plus 15x to the power 3 minus 21x to the power 2. How we can think for this one? What idea do you have?
3x squared.
3x what?
3x squared. 150.
Dividing it all by 3. No, you cannot be dividing all of this. When you divide it, it's called solving the solution. But here we factor. Factoring is different about solving the solution. Justin, he said common factor of x squared. This right. This is true. But what about the numbers too? Angel, he said 3x square common factor. This is nice. Yes. Martin, he said factor it all by 3x square. Nice. So we're looking for the greatest common factor for the numbers. What's the greatest common factor for numbers? 3, 15, 21. Which is it? The numbers only. Is it 3? Why? 3, 15, 21. Number 3 is the greatest common factor. Now, I'm looking for the variables. What's the greatest common factor for the variables? X squared, X cubed, X raised to the power 4. What is it? It's X squared. So this is my greatest common factor. Now I dividing this by that, and I get what I get. What I get?
Square.
X squared, exactly. Plus
5.
5
X.
x
7. Negative 7.
minus negative 7. Okay. Minus 7. Exactly, Martin. X squared plus 5x minus 7. Now, can I factor this one? Can I factor it? If I'm looking for two numbers, multiplying is giving minus 7. And the sum of these two numbers, they give me 5.
No,
Can I
there's none.
count?
There's none.
No, I cannot. So this is the simplest form for this question. I can't find the factor for more for this question. So I keep it until here. Make sense? So this is my factoring for this one. Okay, this is about section 1.3 for algebraic expression. Now we're going to go to new section 1.4 rational expression. Any question before we go to the next section? Makes sense for all of you? Okay, 1.4 rational expression. So what's the meaning of rational expression? Like I said before, algebraic expression, any like numbers and variables combined together by sum, subtract, multiplying, or by power is called algebraic expression. Now for rational expression, it's a fraction expression such that the both of numerator and denominator are polynomials. So rational expression, I give you a brief definition for this one. Is fraction fractional expression such that both of numerator and denominator are polynomial. in other words, rational expression is equal a fraction. Look like this. Such that this is polynomial and this is polynomial. And what is the mean of polynomial? Like the first slide. This is polynomial. This is the definition of polynomial. An xn plus an minus 1 xn minus 1, such that n is natural number and this is real numbers. This is called polynomial. This is example of polynomial here. And the next slide, I said this is not polynomial. Why? Because the power here is not natural numbers. So this is rational number is a polynomial over polynomial. Example of rational numbers. Two x over x minus 1. This is rational expression. Why? Because the numerator and denominator are polynomial. What about something like that? Y minus 2 over y squared plus 4. This is rational expression. This is polynomial. Yes, it's polynomial. This is polynomial. Yes, it's polynomial. So this is the rational expression. What about something like that? X over square root of x squared plus 1. This is rational expression. No, exactly, Martin. This is true. Knowing this is true because we have radical. Radicals is not a polynomial. Radicals is mean 1 over 2, the exponent. So the exponent 1 over 2, this means not polynomial. So this is no, not rational expression. This is yes. Yes. And this is also yes. Okay. Now let's go to something called the domain of the expression. So moving to the next slide. Finding the domain of the expression. So what's the domain? So again, rational expression is a fraction. Has a denominator and numerator. What's the domain for expression? Anyone hear about this definition? Domain.
Domains are all the values of x in which
What is that?
the fraction or function is equal to 0.
What is that again? Angel? Okay, let me give you a definition of domain. It's a set. This set has real numbers. Set of real numbers. Domain are all value of x. This is true, but I want to give like general definition of domain. Its set has real numbers such that this real numbers, when I plug it inside the expression, it keep me defined. Okay, make the expression will define. What does that mean? Like, let me give you example and explain what does mean keep the expression defined. For example, I have here expression, and I have here the domain. So the domain is a set. Okay. So 1 over x. Suppose my expression 1 over x. What is the domain? I mean, like, what I can plug inside this expression such that this expression keep me defined. Can I plug positive numbers like 1, 2, 3, 4, 5, 6? Let me try. If I plug 1 over 1, it will be defined. 1 over 2 is defined. 1 over 3 is defined. So any positive integer keep me defined. What about if I plug negative numbers? Minus 2, minus 3, minus 4. Yes, it keeps defined. But what about if I plug the 0? 1 over 0 is defined? No. So this is mean exactly. So this is mean I can't plug the 0 inside this expression. This means the domain here is all the numbers except the 0. So in math, I can set that x such that x not equal 0. This means all real numbers except the 0. Okay. So the domain here are all the real numbers except the 0. I give you another example. Square root of x. What's the domain for square root of x?
All positive numbers and
Or what about the 0?
all number greater than 0.
So all numbers greater than 0. What about 0? If I plug the 0, will it define? The square root of 0 is
Square root of 0 is 0.
yes. So
that's defined.
yeah, who is that? Will?
Yeah, that's me. Hey.
Okay. So he said all the numbers, all the positive numbers and the 0. He's right. He's right. Why? If I plug the 0, what's the square root of 0? Is 0. So we'll define. What about the square root of any positive number? Still defined. But if I plug here negative numbers, it will be undefined. So how can I express this? X such that x is greater than or equal 0. This is the domain. All the numbers from 0 and above. Make sense? Okay, what about this question? 1 over the square root of x. the domain here? What is the domain? X greater than 0. This is true. Look, if I plug the positive, true. Can I plug the negative? No, I cannot plug the negative inside the square root. So the negative makes the expression undefined. What about the 0? I can plug the 0 inside the radical square root, but 1 over 0 will be undefined. That means I have to remove the 0. So this is mean the answer is x such that x is greater than 0 without the 0. Okay? Makes sense? So all real numbers are greater than 0. Now, let's go to the example, more example for that. Any question before we move to the next slide? Okay. Oh, by the way, this note, I sent it a link for all notes in the Blackboard. So go Blackboard, you will see like the class note, this note. I posted after the class. Example. Find the domain. Number 1, 2x squared plus 3x minus 1. Number 2, x over x squared minus 5x plus 6. What's the domain for the polynomial? This is a polynomial. What's the domain? What I can plug here and keep the polynomial defined? Angel, he said all real numbers. What about the negative numbers? Can I plug negative numbers here? Minus infinity to infinity. This is true. Can I plug the positive numbers? If I plug the positive, they keep defined. So good. Can I plug the negative numbers? Yes, I can plug negative numbers. Can I plug the 0? 2 times 0 plus 0 plus 3 times 0 minus 1. Yes, I can plug the 0 too. So that means the domain here, all real numbers. From minus infinity to infinity. Or in different words, I can say x such that x belongs to the real numbers. For the second one, what's the domain? Can I plug the first things I have something like that, I have to factor the denominator because I'm looking for something makes the denominator not equal 0. So this means I have to factor the denominator, because if I factor it, will be easy to know what's the zero for the denominator. Then I will remove it from the domain. So what is the factoring for the denominator? Like previous section, I'm looking for two numbers. The multiply for these two numbers, they give me 6. And the sum of these two numbers, they give me -5. If I choose -3 times -2, they give me 6. -3 plus -2, they give me -5. So this is the factor, exactly. So the answer, x -3, x -2. So now I'm looking for the zero for the denominator. What is the zero for denominator? What numbers, if I plug it down here, they give me 0. They are number 3, right? Where's the 0? R, what they are? What number, if I plug it here, they give me 0?
3 and 2.
If I plug it 3,
3 or 2.
3 and -3, yes, this is true. Is true, 3 and 2. But let me explain why. If I plug the 3, they give me c -3, and this is 0. And 0 times this expression, they give me 0. So this is true, 3. If I plug the 2 here, they give me 0, and 0 times this one, they give me 0. So the 0 for the denominator are 3 and 0. This means I have not plug these two numbers inside this expression. Why? If I plug this number, they give me x over 0, and x over 0 will be undefined. So what's the domain? What is the domain? This number, they make the denominator zeros, so I have to remove these two numbers. So what's the domain? Okay, the domain is all real numbers except these two numbers, except number 3 and 2. Okay, so in other words, x such that x not equal to and x not equal 3. Okay, any questions so far? Okay, we're going to stop until here for this class. Next time we're going to continue this section.